Hi everyone there. Hope everyone are doing great. And myself, Archana, am of Sri Venkateswara College of Engineering, pursuing my graduation in 6M of EC domain. Today, let's discuss about the topic embedded system design concepts, where it comes under the embedded system course under the module 4. And let's discuss about its characteristics, importance, and whatever the things where the embedded system is playing a very big role in the present scenario. Now let's look after the characteristics of embedded system. Embedded system possesses certain specific characteristics, as we all know that embedded system will be having its own speciality in its field, and these characteristics are very unique to each embedded system. Some of the important characteristics of an embedded systems are application and domain specific, reactive and real time, operators in harsh environments, and distributed, small size and weight, and power concerns. Now I am going to discuss each and every point in a described manner, or briefly I will just explain it. So the first characteristics of an embedded system is its application and domain specific. Each embedded system has certain function to perform, and they are developed in such a manner to do the intent function only. They cannot be used for any other purposes, as we know that. And for example, the embedded control unit of a microwave oven cannot be replaced with an air conditioner embedded control unit, because the embedded control units of microwave oven and air conditioner are specifically designed to perform certain specific tasks. As we know that each embedded system is performed based upon its task, and based upon the requirement of a customer or anyone. So upon their depending or upon their requirements, the each embedded system will be prepared, and it will perform its own task based upon the whatever the importance or whatever the inputs we had been given to perform or to get the result from that embedded system. The second characteristics of an embedded system is reactive and real time. Embedded systems are in constant interaction with real world through sensors and user defined input devices, which are connected to the input port of the system. Any changes happening in the real world, which is called an event, are captured by the sensors or input devices in real time, and the control algorithm running inside the unit reacts in a designed manner to bring the control output variables to the desired level. Embedded system produces changes in the output in response changes in the input. So they are generally referred as reactive systems. As we know that the embedded system will be very responsive based upon the system and based upon the input we have been giving. And also it is an real-time application in the present generation, where most of the electronic gadgets or electronic equipments or electronic devices are running by the embedded system. So where it plays a very important role in the present generation and as well as in the future time also. Real-time system operation means the time behavior of the system should be deterministic. The system should respond to requests or tasks in a known amount of time. A real-time system should not miss any deadlines for tasks or operations. It is not necessary that all embedded systems should be real-time in operations. Embedded applications or systems which are mission critical, like flight control system, anti-clock, or etc., are the real-time systems. Characteristics of an embedded system is operates in harsh environment. The environment in which the embedded system should deploy may be a dusty one or high temperature zone or an area subject to vibrations and shock. System placed in such area should be capable to withstand all these adverse operating conditions. The design should take care of the operating conditions of the area where the system is going to implement, and we can read out the examples. If this system needs to be deployed in a high temperature zone, then all the components used in the system should be of high temperature grade. And also the power supply fluctuations, corrosion and component aging, etc., are the other factors that need to be taken into consideration for embedded system to work in harsh environments. The fourth characteristics of an embedded system is distributed. The term distributed means that embedded system may be a part of a large system. Many number of such distributed embedded systems form a single large embedded control unit. For example, an automatic vending machine, an automatic teller machine, and also a typically example of a distributed embedded system is the supervisor, control, and data acquisition system were used in control and instrumentation applications, which contains physically distributed individual embedded control units connected to a supervisory model. And in an automatic vending machine, it also follows the same thing where it contains a card reader, a vending unit, etc. Each of them are independent embedded units, but they work together to perform the overall vending. And also the same thing which has been working even in the automatic teller machine which is in our ATM. The fifth characteristics of an embedded system is small weight and size. Product aesthetics is an important factor in choosing a product. For example, when you plan to buy a new mobile phone, you may make a comparative study on the pros and cons of the product available in the market. Definitely, the product aesthetics like size, weight, shape, style, etc., will be one of the deciding factor to choose a product. However, when we are choosing a cloth, we'll look after the size, weight, and color, and also the combination and everything. Whereas even in the electronic gadgets, the size, lightweight, and also the like whatever the battery and features regarding the respective embedded circuit or a system, we will look after it. So similarly, we will also see the small weight and size regarding the product. People believe in the phrase small is beautiful. Moreover, it is convenient to handle a compact device than a bulky product. In embedded domain, also compactness is a significant deciding factor. Most of the application demands small sized and low weight products. Last characteristics of an embedded system is power concerns, where it plays a very important role in an embedded system. Power management is another important factor that needs to be considered in designing embedded system, as I already told it. And the embedded system should be designed in such a way as to minimize the heat dissipation by the system. The production of high amount of heat demands cooling requirements like cooling fans, which in turn occupies additional space and make the system bulky. Select the design according to the low power components like low dropout regulators and controllers processors with power saving modes. Also, power management is a critical constant in battery operated application. The more power consumption is, the less is the battery life. So these are the few references where I had given where you can go through the embedded system detailedly and you can also study its architecture, programming, everything from A to Z of an embedded system. Thank you for watching my video.